Hello and welcome to the screencast. Tonight I'm going to solve some of the problems you might see on tomorrow's quiz on solving rational equations. When I solve a rational equation, the first thing I need to do is factor all of the denominators. I never factor the numerator, only the denominators. So in this problem here, this equation here, the factoring is already finished, so I'm just looking for the least common denominator. Now, the least common denominator is going to have a 4 in it, and as far as n goes, I need to find a fraction that has the most occurrences of n, and I need to use the exponent from that fraction. So the most times n occurs is twice, so I'm going to use 2 as an exponent of my LCD. Alright, at this point I usually rewrite the equation, leaving myself room to write in the LCD over 1 in front. So, because I'm going to be distributing 4n squared over 1 to each of the three terms. So now I write in the LCD over 1, and now I'm ready to cancel out terms that appear in both the numerator and denominator. So all terms cancel out in the first for the first fraction. In the second fraction, one of the n's does, and then 4 over 2 becomes 2. So let's see. And then over on this side of the equation, both of the n's cross out, and I'm left with 4 over 2, which is just 2. Now I have a simple linear equation to solve. So I'm just isolating the variable, and I'll divide by -2. And I get n equals 3/2. Alright, now let me look at the next problem. Well, the next problem, k only occurs once. Well, first of all, there's going to be no factoring involved. Then I look at trying to find the LCD. So the LCD is going to have a 4 in it, and it's going to have a k. So I'm going to be multiplying by 4k over 1. So let me recopy the equation. And now I'm going to write in my 4k over 1. And cancel factors that appear in both the numerator and denominator. And this will become a 2. So far I have that, which is equal to k plus 5. Now I just have a simple linear equation to solve, which I do by distributing and then isolating the variable. So let's see, this gives me -6 plus 2k equals k plus 5. So I'm going to add 6 to both sides. And I'm also going to subtract k from both sides, and that leaves me with k equals 11. And that is my solution. When you have a linear equation, as a result of clearing the fractions, you will only have one solution. Okay, in the next example, I am going to need to do some factoring initially. So factoring, I get that. Okay, the LCD is going to have at least one of each factor. So my factors are k and k minus 3, and each of those factors only ever occurs once in any of the fractions. So I know I'm not going to have to add any exponents. So I'm going to be multiplying the entire equation by k minus 3 over 1. And I'm going to have to distribute. So let me just recopy the problem. And then let me write in k times k minus 3 over 1. Secret word tonight is snow day. Alrighty, let's cross out terms that are in the numerators and denominators. And that's that. So what is that? What am I left with? Here I'm left with a 3. Here I'm left with a k minus 3. And here I'm left with 1. Now I have a pretty simple equation to solve. So 3 equals k minus 2. I'm going to add 2. And I get my solution of k equals 5. Okay, moving right along. Alright, in these next two problems, or equations, I'm going to end up with a quadratic equation to solve, which I will explain when we get that far. But other than that, the problem starts off the same way, or the technique. I first want to find the least common denominator. Well, for this equation, it would be 6v squared. So that means I'm going to be multiplying by 6v squared over 1. So let me recopy. And now I'm ready to cancel terms that appear in both the numerator and denominator. So here I'm going to get 2v squared, and then here I'm going to get v squared, and then lastly I'm going to get 1. Alright, so now I have a quadratic equation to solve, and typically I want you to solve it by factoring, although this one you can solve by taking square roots. But let's factor just so that we can be consistent. Now to solve an equation by factoring, you have to get one side of the equation equal to 0 before you factor. So let's do that. Alright, I can combine like terms here, giving me v squared equals 1. Then I'm going to subtract 1 from both sides. So that gives me v squared minus 1 equals 0. And I need to factor. Okay, v squared minus 1 is the difference of perfect squares, which factors to be v plus 1, v minus 1. And that means my solutions are v equals negative 1 or v equals positive 1. Alright, now I could have also used the square root method to solve the equation v squared minus 1 equals 0. So let me show you. Well, actually, I think I'd go even back farther than that. Yeah. If I had v squared equals 1, some of you may remember, you can solve that by taking the square root of the left, the plus minus square root of the right side, giving me v equals plus or minus 1. So you get the same answer or the same solutions either way. Right, and finally I have this equation, which I'm going to have to factor before I figure out what the LCD is. So a squared minus a factors to be a times a minus 1 because that is a common factor. And that means my LCD is going to have, an a minus 1, and it's going to have an a, and it's only going to have one of each. So I'm going to have to multiply everything by a times a minus 1 over 1. So let me do that. Let me first recopy the equation. And now I'm multiplying by a minus 1 over 1. And now I'm ready to cross out terms that are in both the numerator and denominator. So in the first term, pretty much cross out everything except for 1. Second term becomes 6a plus 5. And then in the third term, only the a minus 1's drop out, and I'm left with a times a plus 5. Okay, so to solve that equation, I'm going to have to distribute, collect the like terms, or move all terms to the right side of the equation, and then factor. So my first step is to distribute. Let's see. Okay. Oops. Just caught something. That's a 5. Okay, so I'm going to combine like terms while I'm doing that. So this would be 6 plus 6a. This would be a squared plus 5a. And now I need to collect all terms on the right, or on one side, and I'm going to move those terms to the right. So I'm going to end up with the quadratic equation a squared minus a minus 6 equals 0. That's a trinomial where I need two numbers that multiply to be negative 6 that add up to negative 1. So that would be negative 3 and positive 2. And that means the solutions to the equation are a equals 3 and a equals negative 2. And now let me check to make sure neither of those are extraneous. So do 3 or negative 2 result in division by 0? No, they do not. So I know I'm all set with the solutions of 3 or negative 2. Alright, I hope you found this screencast helpful, and that you'll get a good night's sleep. And since I won't be there tomorrow, please be kind to the substitute, and have a great weekend. Cheers!